So this is the next thing I'm going to be doing a bit of a review on. So once again, it's been supplied by Rob from AWG Technologies. So again, here's his website address, his email, if you're interested in one of these things, in New Zealand of course. And you know, he's been very good at lending me this piece of gear, as well as the that brand new oscilloscope I did a review on as well. So this particular unit has been around for a few months, I believe, so it's not like a new thing. You've probably seen this anyway, but I'm going to do a review because it's a different spin on things. Well, I do reviews, it's not the same as the way everybody else does it, so we'll have a go at it, and we'll have a look and see what this is. So, power cable. Go. It comes with a USB cable to A to B cable, which I'm not going to be using right now. Also comes with a USB to crocodile clip. A BNC to crocodile clip cable. So nice 3-link connector there. Feels like it's going to be, you know, reasonable quality at least. And manual. So we have here an SDG1032X series. This particular one is the 32X, so this is a 30 megahertz version. Let's just adjust it slightly. Oh. It's all going wonky. Right. There we go. Right, so unpackaged it. So it's 30 megahertz version. So a manual, quick start guide, which gives you the basic stuff or safety stuff, or CD there, software and manuals on it, I'm sure. Quick start guide, you know, adjusting the handles, familiarity with the user interface in the front panel, usual sorts of things, introduction. Yeah, just brief overviews of what the buttons do. Rear panel, so it's got a frequency counter input, auxiliary in and out, which will probably be modulation, I'm guessing, audio, and 10 megahertz in or out. So I can use the internal reference out, or you can inject a 10 megahertz reference. So I'm not quite sure what the spec is actually as the internal reference. I don't know if it's a TCXO. I don't think it's going to be an OCXO, but it's probably a TCXO. But it could be just a crystal oscillator. I don't know. And it mentions about the EasyWave software, which you can use to interface with the PC. So that's that part. And one more thing, it's gone wobbly everywhere. Certificate of calibration. Although interestingly, yeah, that's right. Just so it shows Agilent test gear, digital multimeter, and power meter are used for the calibration. So yeah, all good. I'll come back and do some more shortly after I've familiarised myself a little bit with the unit first. I'm going to play around with it, get used to using it a little bit, because I haven't used one of these before, new to me, so I'm not familiar with it. So I'm going to learn it a little bit myself, then I'll come back and do a video and show what I found, and you know, how to use it once I figured it out. So I'm just playing around with combining waveforms. So in here you got utility, output setup, wave combine, and then you can choose different ways of combining the waveforms. Right, so the output will then be for channel 1, channel 1, channel 2, channel 2. That's all separated. You can see here like a graph of how it joins them together, which is, well, a graph, a diagram. So you can turn 1 and 2. So channel 2 then becomes a combination of 1 and 2, or both channels become a combination, or just one of them, you know. So that's a nice little thing. You can change what you do there. Now what I'm doing here is I am on channel 2. I'm doing a triangle wave, 500 kHz, and on channel 1 I'm doing an up ramp, which is one of the arbitrary waveform types. Okay, so up ramp here in common. Now what the output there ends up being is quite interesting. So you're combining that with that. So what you actually get on the output is this. That's the actual waveform coming out. Pretty interesting, isn't it? Now, it gets a bit more interesting. If I then get a USB stick like this, plug it in here. Alright. Now, I can now save this setup. Well, save this waveform, right? To a CSV. Let's bring this over here so you can see it a little bit better. Okay. So, CSV option there. So I'm going to save a CSV. Parameters off. I don't want to save parameters. I just want to save the actual waveform. Save it. Now I want to do a new file. Yeah, let's just call it something. I don't know. Z. EZ. Right. Press to save. Okay, waveform has been saved. And interestingly, there it is. Okay, it's doing a weird naming convention thing here. I've already reported this to Siglent, and I'm guessing that'll be fixed. It's just a little bug where it's dealing with file names externally. It's a bit weird. It's nothing major. It does save it. You just have to choose the correct one because it's appending a 1 to the end of the file name. Well, appending a number to the end of the file name. So that's, you know, it's fine. I called the first one, Eve's default was E, which created 1. I called the second one Z, and it created 2. So you can see the file 0k or 0 bytes. So Siglent's been notified anyway. So I mean that'll be something I'll fix in the next update, I'm sure. It's not a big deal. So E2 is the one I want to use here. Okay, so I'm going to get back out of this. Put a USB stick. Plug the USB stick into this one. Just try not to drop the camera in the process. Okay, so now let's store and recall. If I can just do a recall directly. Okay, so I'm not quite sure how to use that bit. So waveforms. I want. I lost myself. Arbitrary waveform. There we go. Arbitrary. Arb type. Stored waveforms from the USB. Now there's the EZ, which I'll say, but it's going to be blank because it didn't say the data. So I want the E2. Okay, here we go. It's imported that waveform, and there it is. Right, so that's the waveform that was on the scope before. So you can generate a waveform, combine it, output to a scope, save it on a scope, bring it back in as a waveform, as a proper arbitrary type. So then you only need one output again, because this one output can do that signal. Alright, confused yet? Nah, it's not that bad. So that's a nice little touch. You know, having two Siglent devices like this means you can do that kind of thing. So if you want to create a really complex waveform, you can actually layer it one on top of the other, you know, and build it up. You can do all kinds of weird stuff. So you can actually, in theory, you could actually create a pulse map or something, you know, a bunch of pulses, and then insert pulses where you want them, and then you know, do that onto the scope, and then save it, bring it back in, add another pulse. It's almost limitless what you could do if you have the time and you want to work, figure it out. There's software you can do as well. You can put it straight in that way, and I believe I haven't tried that yet, but it's supposed to be able to do it. Okay, so that's now the waveform, and as you can see on the scope, it's now trying to combine the original waveform with the new one. Now look at the state of this. Right, that's now the waveform. Look at that. So it's combining that dual waveform with whichever one the other channel is using. This is on channel 1, so channel 2 is doing a triangle wave. Here we go. Right, so it's combining that waveform with that one, and we then get that. So I mean, look at the things you can create with this. It's quite incredible, really. You know, just look at it. And if I wanted to do this differently, I could say, I'll leave it on normal triggering for now. Let's change the waveform type on this particular one. There you go. I've now put a pulse on instead. Right, so instead of being a triangle wave, it's now a pulse, and you get that waveform. So I mean, look at this. You know, the stuff you can do with this. You know, effectively you're artificially creating slopes on the waveform, so you could maybe test triggering of a digital signal, for example, on this particular example. You know, where it's got slopes and it's not nice and clean, like, you know, nice hard edges in that way. I mean, I don't know, maybe there's something with that, but what else is there? You know, you chuck a sine wave on it, it turns it into like a triangle wave again, which is interesting. You know, or you can put noise on, and then you get that. So it's just yeah, I can go back to that again. So it's just incredible what you can actually do on this thing. You know, there's a pulse with the original waveform, I think. Yeah, there's the original waveform with a pulse on it. So it's, in fact, you can just, you know, build a waveform even in some part on this unit and get something like what you want. Obviously, you won't see the actual waveform until you know, unless you actually import it or something. But you know, you could get some kind of waveform that you can see on the scope, which is close to what you want. Save it on the scope, bring it back in here, tweak it a bit more. You know, that might then give you one. Or if you need, say, literally, if you need more than one signal, you could combine the two signals into one at this point, and output that to this process, and then it gives you effectively a third layer, because you can inject another signal from the second channel. Right, you can see I've got a second channel hooked up. Now you can see. Right, so that's just purely the internal routing. So, you know, it's a nice little feature that it has. That whole coupling thing. And you've got other features in here too. I'm not quite sure what this is doing. So you can couple the outputs together. That's right. So you can couple the outputs together. So you can then, if you adjust one, adjust the other one, and so they stay relative to each other, which is also quite a nice little feature. Yeah, it's nice. I do like it. This is it's got some little quirks in there, and I've notified those Siglent as well. Just things which I think could be improved upon. Not really bad things. They could be made better. Right. So let's see an example I can give you. Right. So when you're doing individual steps, it's, you know, responding just fine. Okay. But if you want to go fast, it doesn't actually get any faster. Alright, so it's got a little bit of debounce issue in there. Just need to set some debouncing up in the software, I think. Because you get really fast, it can actually go downwards instead of up. You know, that's a common thing with audio encoders, just trying to get that timing and debounce exactly right. It can be a bit tricky sometimes. You know, if it's not done hardware, it looks like it's done in software, so, and that makes it harder. Because then you have to do it on timing and things like that. But it's and a bit of logic behind it, but it's not insurmountable. So this could be improved. I mean, it can make this much more responsive just by tweaking the algorithms for the radio encoder, and it would actually make it feel much more responsive and it'll just feel nicer. The other little quirk that I don't like on it, some people might like it, but it doesn't agree with me, is, say you got a frequency here. I'll compare you to frequency. Currently set at 500 kilohertz. So if I come over here and I want to change by, say, 100 kilohertz steps, right? That's fine. Right, up and down. But when I get down to there, it suddenly goes by 10 kHz steps. I've moved the cursor over, but because it's gone out of range, it's moved it to the next digit. Okay, which you can understand. Right, but if you're trying to do big steps and you go down by range, like now I've gone down to 9 kHz, but now I'm going up by 1 kHz of steps, and I don't want that, you know. Whereas, but I was doing 100 kHz steps before, and now I'm doing 1 kHz steps, and I find that a little bit inconvenient. You know, if I want to do big steps, I want to do big steps. I want to have the cursor over here, and I want it to stay there. So if I do up again, oh, too fast. And I'll go back up and 4 steps again, right? You know, so that's jumped over. So this time it's actually stayed in the right place because I was doing 100 kHz steps. Right, if I'm going from here to here, it stayed correct. You know, that is actually working correctly at that point there. So, you know, I like that. That's acceptable, right? But so when it's changing the actual digit it's doing, you know. One of these ranges, I can't remember which one it is now. I can't remember which one it is, but he gets up to the top of the frequency coverage, and the cursor jumps to the least significant. Right, so it jumps from the leftmost bit to the rightmost digit. So if you're doing, you know, going down by megahertz, and suddenly you're doing kilohertz, or yeah, kilohertz. So it's little things like that. But most of me fiddling around with this and trying to get my head around it and get used to it is literally just me trying to figure it out. No, I've never played around with one of these before, so it's a bit of a case of me learning how to use it and finding things which don't work quite the way I'd expect them to. Not necessarily working incorrectly, they're just not what I'd expect, and it doesn't, you know, mean a bad thing. But it may mean that some things aren't as user friendly as they could be for people which are just starting out to use the instrument like I am right now, and that they're trying to learn how to use it and just get used to the user interface and that sort of thing. But it could be easier, and that's what I'm trying to look at. You know, I'm trying to look at usability and a bit of feature stuff. You know, I'm trying to show features, but usability is the main thing I'm looking at. So I'm trying to see ways of what makes it easy to use, what makes it not so easy to use, what could be improved upon, and the improved upon thing is quite important to pick up on, because product development and any kind of thing you create, you have to know what could be done to make it better, and that's an important thing. And people, you know, slate companies like Siglent. I know there's some haters for Siglent. You know, I've seen a bit of that in the forums. It's people just dead against them and just slagging them off all the time for over little things. And unfairly so, I believe. If it's sometimes, you know, products get bugs because how complicated these things are, the complexity in them. So trying to deal with that is interesting. And you know, looking through these little user interface quirks and telling them, hey, this could be done a bit differently, and it would make it easy to use. Feeding that back is good, because then they actually know what they can do to improve it. You know, from a newbie's perspective. So right now I've just got channel 2 set up as a pulse, just some default stuff. I haven't tweaked any values, and channel 1 as a sine wave, and the result of that is this. So it's a bit like a run pulse, but with sine waves, and it's, you know, that could be quite interesting. You know, that could be good for doing some testing on things, to see how it handles this weird behaviour here. You know, going down instead of up. That could be a little handy thing to play around with for someone. So I've got the 1032X hooked up to my Spectral analyzer, so I'm just holding the camera, so it's going to be a bit shaky. So I've got this set at 100 kHz span. You can see the actual frequency. I've got it running really slowly to try and be anything. There's a little bit of a spike just here. It's not too bad. There's a little bit there, so that's pretty good. Yeah, it's not bad at all. So let's just go back to, let's go border span. Oh, other way, border span. Let's go. Yeah, a couple of megahertz. All right, let's see how that comes out. I'm going to need to adjust some settings on here. What I'm looking for. I've forgotten. I'm just trying to find this. I don't use this thing that often. Not as often as I should. Adjusting reference levels. Here we go. Go around, maybe. Here we go. Now got noise floor. Okay. There you go. So that's with 5 megahertz bandwidth. So 10 megahertz bandwidth. This is a 10 megahertz frequency. So you might start seeing harmonics. Let's go 20 megahertz. No, it didn't see anything. This is now 50 megahertz bandwidth. So now we are starting to see some stuff there. So that's 0 megahertz there. That'll be. Let's just quickly up it off. So that'd be like the 0 marker, I reckon. Yep. So that's the 0 marker there, and that's the actual output there. Okay. So this is a harmonic here. In here. So let's go to actually let's drop the span back down a bit and shift the frequency up. Let's go 20 megahertz. Okay, there's one harmonics there. Is minus 85 dB when I picked it up, minus 86 dB. So let's go 40 megahertz, see what's there. Yeah, it was a little blip just there. That's minus 97 dBm. So that's not too bad really as far as harmonics go really. Yeah, so, and I thought let's show that and have a little play around with that. Having a really slow speed makes it a bit tedious to go through it, but you know it's alright. Yeah, that's all good. So I mean it looks pretty clean really. I mean this isn't the best thing to pick it up on. It's an old spectrum analyzer. It's an old 8590, sorry. Yeah, and it does pick up quite well, but it's certainly not as good as some of these more modern units. I mean, you see the noise floor there if I play around with it a bit. But yeah, it's alright. All good. So I thought I'd show that. You know, it's pretty clean output really, from what I can see. Alright, so I'm going to do some review stuff on this SDG1032X. It's a bit hard trying to find some kind of review that I can do which hasn't been replicated somewhere else already. There's a lot of there are reviews out there for this. Some more detailed than others. Some are really basic, just a very much of an overview. So I'm going to try not to replicate too much, but there will be replication obviously because you can't avoid that. But so let's look at startup time for start. I believe it actually starts up fairly quickly really. If you look at some of the other videos online, they seem to be slightly slower, so it might be this version of firmware is a bit better. I haven't timed it, I could be just that, you know, that's the way I'm interpreting it. I have played with some settings in here, like some of the stuff you can do is phase lots independent channels, so they, you can do synchronization between them. The clock, 10 megahertz output, you can turn it on and off. That's on the rear panel, and it's internal clock into either internal or external, so it checks to make sure there's an external clock before it actually lets you switch, which is a good thing. Sync, I haven't played with this yet. I'm not too sure how this works, so that's something I haven't looked into yet. Interface, you've got GPIB in there, LAN as well, so you can do DHCP. I haven't set any of this up, so but you got something mask, basic stuff. Okay. Obviously, it doesn't list USB, but USB is always on, so it doesn't have a selection. You plug it in and use the software, and it will work. The software is something I may have a play around with. My computer's not agreeing with it, so it's a bit old and a bit clunky, so it's not enjoying it, because my main computer's a Mac, but I've only got an old PC laptop, so it's at least the one I can use for doing this kind of testing, at least. So back here, test cow, so you can do a self-test here. There are hidden menus, which I don't know if I should show you or not. It's probably safe to show you, actually. Yeah, I might show you that anyway. So this is the frequency counter option. So you can plug in a connection on the rear, and you can use it as a frequency counter, which is in this section here. You can turn it on and off. If it's off, it just does nothing. And then choose frequency or period. Here's and it gives you deviation and stuff like that. And you got widths and reference level, trigger levels. So it's quite covered. High frequency rejection, you can turn it on and off. I think that's above 250 kilohertz. It'll reject, I believe. AC/DC coupling as well. So I think normally for the HFR you'll leave that turned off, because it's okay if you're only doing like audio stuff, for example. That'd be fine, or below 250 kilohertz, but above 250 it starts cutting it off. So that's the reason behind that. Yeah, so I should actually inject a signal in this, shouldn't I, and show you what it does. I should do that. Let me find a cable. Hopefully I've got one. You might have to bear with me. Here we go, here's the cable. It's not a perfect cable, but it will do the job. Let's just get this hooked up, and then I'll come back in a second. Okay, so I put this up to my Marconi signal generator, which is obviously warming up, and it's going to be a bit flaky. This reference frequency thing here is supposed to allow you to offset. Actually, let's just do it this way, a bit quicker. 10 megahertz. Alright, so if you use an offset frequency, it should do some kind of offsetting for the deviation. So you can use this as like a set point. So if I said 26.5 megahertz, it tells you how far off it is from that set point. Okay, so if you're doing like a known measurement, this will tell you how far out it is. So you've got ppm and displayed here, and that's quite nice. Clear it so it starts again. So yeah, it gives you, there you go, 2.9 ppm, for example. So that's quite a nice little feature there. So you can, instead of having to sit there calculate it, it just tells you. That's really nice, as long as you know what frequency it's supposed to be getting. However, the internal reference on this is very slightly off frequency. It will depend on temperature a little bit, but in my case, this is off by about, once it's warmed up a little while, it's off about 40 hertz at 10 megahertz. So at this frequency, it's off by about 100 hertz or so, which actually correlates to what we're getting here. Right, so that's about 97 hertz off right now. So and say everything's still warming up. This is still warming up. I've only had this on for, as you've seen, a couple of minutes, and the Marconi's also been only on for a couple of minutes. So everything's still warming up. So there's nothing actually settled down. But the actual reference in this, it is very stable. I do like the reference in it. It's not. It doesn't see a lot of drift on it. And I've done a little test on it. We had the Marconi on for a period of time to have it warmed up. Then I've turned this on, and I've looked at the frequencies, and it's been really good. It's actually showing it quite nicely. It's not really drifted that much. I should have actually measured it and seen how much it was, but it was actually minuscule. It's not like you're getting a 1 or 2 kilohertz drift. You're talking about hertz. It's not much at all. I do like the reference in it, but it's just not quite on frequency. So one of the things I've actually suggested to Siglent is to actually, in one of the hidden menus that's in this, well, the hidden menu that I know about, is to add a function to allow you to calibrate the reference. I don't know how possible that is to do, because obviously the reference is also fed out the back as a 10 MHz reference, so it may not be possible, but it's one of these things you can ask. So yeah, I mean, the figures kind of works. You can see the accuracy here; it's pretty good. You can't tell it the gate time, I don't believe. I'm not really. That's a shame. Yeah, cycle widths. So yeah, I don't think you actually set like a gate time on it. It just reads what it reads, and it thinks the gate time is enough for this accuracy level. You do see a little bit of jumping around here. The gate time's probably, what was it, 0, 1, yeah, about 2 seconds gate time roughly. I'm not counting obviously, but yeah, 2 or 3 seconds gate time, something like that. So obviously that's sufficient time to get the readings. But so this reference frequency here, that's obviously just. I wasn't sure what that was for originally, because thinking reference is internal reference, so I actually misunderstood that to be you could set the reference frequency, because it actually happened to be 10 MHz, right? So that threw me a bit as well. But that's all this is for you, so you can set the ppm variance and you can see what it's supposed to be versus what it actually is. But so the internal reference on this is slightly out, so but it's still pretty close. It's probably good enough for most people. But as I do radio work, it's for me, it's a little bit far out, but it may be nothing. So it may be tunable somewhere. There might be a way of doing it. So what else we got in here? Counter output setup. So you got the load settings. Now this load setting could be easily misunderstood. There's actually 2 ways of doing this. You can hold the output button down. You gotta turn it on first, and then hold the output button down, and it'll switch it for you. All right. So you do a long press. So it's a shortcut straight into it. But all it actually does is it changes the display. It doesn't actually change the loading, because this is a source. The loading should be based on the device it's connected to. Okay, so if you're connected to a scope, you should have 50 ohm loading on the scope. Alright? But if you do that, your voltage reading here won't be accurate. So it's based upon you set that, and it changes the voltage reading to be what it would be into a 50 ohm load. Okay, so that's purely for the display of the voltage or the amplitude. Volts or dBm, whatever it's set to, right? But it's purely for display. It doesn't actually change anything. There's no load inside the unit. It just changes voltage, so you can see here what is actually being delivered to the device. So it's easily misunderstood. It threw me originally, and I did some reading. It's actually in the manual. It's quite early in the manual too. Right. But I like to play around with things before I do that. So back in utility again. System, I'll show it. Number formats, you can change the number formats. So it's got decimal places here, or you can make it commas if you prefer that. The separator here, well, then that one there, that's a space currently. You can change it to no space if you prefer, or comma. I personally like a space. Power on as well. This is a nice little feature. Oh, you can change language. Just to see what's in here. All these different languages in here. I don't know. I seem to have lost English. Yeah, there we go. Yeah, scary. Now, last power on. Well, power on. You got choices here for whether you load the default setup at power on or the last used settings. So default. So it means it starts at was it 4 volts peak to peak, and I think I can't remember what frequency is on any of it. But default settings. Personally, I prefer last power on, so whatever you use last is what comes back on. Beeper on and off, so that's key press beeper. So you know, I quite like having beeps as a confirmation of a button press, so you know you've actually pushed it. Screensaver, I actually recommend you turn this on. It's just a good thing to do. It just blanks the screen off after preset time. So you're 1 minute through to 5 hours. Alright, so you know, I'd certainly say, you know, stick it half an hour, something like that. So if you do leave it turned on, it's just sitting there, it'll just blank the screen. And then if you push a button or something, it will come back up. System info, this is where things can be a little bit interesting. There is a hidden menu on the screen. And there's nothing bad in there that you could mess up. I'm tempted to show you it just for documentation's sake. It is documented online, so yeah, I'll do it. Okay, so when you go into this screen here to see the system data, if you put in 1, 2, 3, 6, 5, 4, there's a hidden screen which allows you to do a self-test and a self-cal. Alright, and I think it's probably a good thing to do a self-cal periodically anyway, but there may be a reason they've hidden that option. I don't know why. You'll think the self-cal will be something which is normally accessible, but this is what I was saying about the internal reference being adjustable. Right, I wanted to put it in this screen, like on the button over here, or one of these, which are free, to allow you to adjust the stated calibration point for the internal reference. So right now mine's out by about 40 Hertz. Well, this one is out by 40 Hertz, and you know, I suggested, you know, you could just enter the frequency that's actually generating, and say, right, it's generating 9.9996, not 10. Right, and or whatever it works out as. That way it'd actually know what its internal reference is, and it could offset that and correct for itself, and give you correct frequency counter readings and that sort of thing. So that's a nice little thing which could be added maybe. I've suggested it. We'll see if anything comes out of that. Counter we're done. Test cal, I mean, this is for the self-test over here as well. So you've got self-test in two places here and in the hidden menu. I haven't tried the one in the hidden menu. I don't see if there's any difference, but up options say load, polarity, so you can reverse the polarity. EQ phase, I don't know what it does yet. I haven't figured that out. Wave combine, this is one which I think I did a bit of a video on that already, but I'm not quite sure how I'm going to piece the bits of video together yet. So I'm just going to cover everything now. So there might be some duplication. Now this, by default, channel 1, channel 2 are completely isolated from each other. So they're completely separate outputs, independent of each other, and identical. As in identical control, identical capabilities. With this combine feature, let's combine it. Yeah, wave combine. Oh, get me, come back out. You can see this diagram shows this symbol to show it can be merged. Right, this is a merging symbol. So channel 1, channel 2 come in. This is just a visualization aid, obviously. Get merged here, come through to this point here. Now at this point it goes both into these output connections here. Right, these are representative of output switching. As you can see, each one right now is set to be each channel independently, but if you come over here you can push that button and then that switches that output there, so that is now the combined 1 and 2 output going through to channel 1, and channel 2 is still independent. So you can do one waveform on channel 2 and combine it with the channel 1. And that's quite good if you're trying to do complex waveforms. I did do a bit of video on this. I think I will be including that after this section, I think. Or maybe at the end of the video, how it fits together. But it shows the waveforms I could get and a demonstration of what I did with that. It's pretty cool. Or you can turn it back to that one, or you can do the same with channel 2. So channel 2 instead is the combined output, and channel 1 is a straight through. Or you can do both. So both channels are the combined output. Alright, so if you need like 2 outputs or something, because you haven't got a T connector, for example, you could do that. You know, but that's nice and flexible. It's a nice, simple display. I really like that. It's easy to understand. You can see what's doing. You know, that's well designed. I like that. Okay, so channel coupling. Tracking, I haven't played with that yet. I'm not too sure what that's doing. I've forgotten. I have read it, but I don't remember. I didn't read it very well. I was a bit tired. I haven't had much sleep all week. And you got all these other options in here, which I haven't played with. I can't actually tell you about them. I'm sure they're in the manual. So channel copy coupling. So what that's right now, Amber. Right. So this allows you to duplicate the settings from one channel to the other. So whatever you do on channel 1, in this case, we'll go to channel 2, or in this case, it'll be from channel 2 to channel 1. So they move together. So yeah, it's interesting. So so you can set a frequency here which does that, or frequency volts. It just links them together. I haven't played with this at all. Amplifier coupling, turn them on and off. Right, so I think couple frequency, you can couple the amplitude. Amplitude mode. Yeah, so you can set the difference between them. So you don't have to have them exactly the same. They can be offset from one another, and phase as well. Yeah, again, same thing. Ratio or deviation. So it should be like a variable output. So yeah, it's looks like quite a handy feature. I haven't played with that myself yet though. Interface. Oh, I see. Of course, I'm back to there. I'm back too far. Here we go. Sync clock mode. Again, I think sync was. I don't remember. Oh, these features I've skimmed over now. I'm looking at them now, thinking, oh, what does that do? Oh, voltage protection. I'm not quite sure why you'd ever want to turn that off. I mean, you want to protect the unit from any damage, so I think that'd be a good thing to have just on all the time in case you get some kind of backfeed voltage from a faulty piece of gear or something like that. You know, it's just, yeah, I don't know. I'm not quite sure why you want to turn it off. There's that phase locked independent mode, so it all explains here. It does actually have a built-in help system as well, which I have forgotten where that is. It's not that. Some things have like a button press, you hold it down, it brings up the help. I think it was in here somewhere. What's it in there? Where is it? Help, here we go. Help systems there. Alright, so it's just like a little run through of what's in a unit, and you can just go through the list. Alright. Or you can do it on the buttons as well here, whichever way you want to find easier. So it tells you how to do certain functions, and it's rather basic, but if you're very unfamiliar with the unit, it can be helpful. Right, so there you go. That's that short way to get to that other system information. You know, generating a waveform just describes what you do, and alright. So it can be helpful for people which don't know how to use a unit. I have had a read through it, but it's not as comprehensive as the manual. So read the manual. This is just really more of a prompt and just a reminder. I mean, it's okay. It's a nice thing to have in there. Okay, that's that. Sweep function. Sweep is quite nice, quite versatile. One thing I wish it did though was the. I'll show you. So right now this is sweeping, okay, but you don't know that. You don't know what you don't know. Let's just get the scope set up. And try and get a waveform going. Here we go. Right. Let's just move this over a little bit. So there's the sweep going off there now. Alright, so it's currently doing a 9 MHz start frequency, 11 MHz stop frequency over a time of 1 second. Okay. You can do like a range, so start and stop frequencies, or you can do a center frequency with a span instead. You know, they both do the same, work the same way, but yeah, it just depends on how you prefer to use it. And also you can set the sweep time as well, right? So if you want to go for 5 seconds instead, or 5 nanoseconds or whatever, alright? So now it's sweeping much more slowly. Now what I'd actually like to see on here, yes, it's sweeping, but there's no indication that it's sweeping. Alright, so if I bring this over here, you can't tell, there's no visual indication saying it's actually working. So what I've suggested to Siglent is up here where it's got the frequency shown. In this case it's just mid-frequency, and even if you've got it set on a start-stop instead, that's still a mid-frequency. If I do say 7 megahertz, right, that is still in the mid-frequency. Right? So that always displays you the mid-frequency of the sweep. What I've suggested is that they change this to be a real-time display of the actual frequency as it's sweeping. Right. Now, if you've got a really fast sweep time, that's just impractical. I can understand not doing that. But if you're doing a sweep time where it can be displayed, then it'd be a nice visual indication to show it's actually sweeping. Another thing I've also suggested to Siglent is this sweep is only for frequency. There's no, or apparently to me at least, there's no amplitude sweep. It's only frequency sweeping. And I've said maybe adding amplitude sweep would be a feature to add to it as well, because at least then you got that option of sweeping amplitude. You can have a fixed frequency and sweeping amplitude, or you might be able to combine the two even and have a sweep of amplitude and frequency. So you can do all kinds of weird testing with that. That'd be quite cool. I think that'd be quite nice. You've got a trigger output here as well, so there's an output on the back, so you can actually tie this in, so when it's sweeping, it will send a signal out when it starts to sweep. I haven't played with that yet, but that's what it does. And you can also choose the sweep type, logarithmic or linear, and direction up and down. What they could actually, they could put an option here, say, amplitude or frequency option, just there on the button. Little spares. Anyway, we'll see. We'll see if they can action it. I can suggest these things, and it may or may not be possible. There may be technical reasons why it can't be done. I don't know. But it's worth asking. There's no harm in asking. As it is, the unit is quite nice, and a lot of the things I've been playing with for a few days now. Not a huge amount. I've probably spent 3 or 4 hours playing around with it, really. So I'm still getting to grips with it myself. And I found a few little weird quirks in it, and things which I didn't expect to be doing what they were doing. And all they really were is my interpretation of the way it worked, and I just my encrypted interpretation. So you have to be careful if you do get one of these units. Read the manual. Right? I intentionally don't read the manual until after I've had a play with it, because I like to try and get a first time impression of how something works and how I interpret it and what I find. I think, well, maybe but by doing that first time impression, you may actually come up with ideas of ways to improve it. So that's the way I work, but I do read the manuals eventually, just not straight away. Right. So at the minute, sweep is quite nice. I shall do modulation. Now, one thing is cannot do, and I've also suggested as a possible improvement. It may or may not be possible. I don't know. There might be reasons why it can't be done. You cannot do sweep and modulation at the same time. They're incompatible. So modulation is part of the normal frequency generation, but you cannot do modulation with a sweep, which is a bit of a pity. It would be quite nice if we can do that. So that's another suggestion I've put through, is to allow modulation with the sweep. It may not be possible. It might be something to do with the timings and stuff like that. It might actually mean the modulation is distorted. It might be possible. It might be some kind of thing like that. But if they do add a amplitude sweep instead of a whole frequency sweep, then modulation might be possible, because then it's a fixed frequency and modulation is more likely to be okay. But anyway, so what we're looking at now is modulation. So you've got different modulation types: AM, FM, phase modulation, FSK, ASK, double sideband AM, PSK. PWM is only available under a certain condition. I can't remember what that is. It is there, but there's a certain it's greyed out there because you have to be under certain setting conditions in order to use PWM. It might be a certain frequency setting or something like that, or below a certain frequency range. So you can set the AM as internal modulation or external modulation. So it's got, again, it's got the socket on the back there. You can do that. AM depth and frequency and wave types. So you can do square wave modulation, or triangle wave, and those different wave types. So, or you can use the arbitrary waveforms which are built in, or your own ones. So there's always options of things you can do, which is are quite nice. I do like that. It's default setting there. Okay, so that's modulation. So that works with everything apart from the sweep, I believe. Burst mode. I haven't played with this much, but basically it does this. Alright, so that, if I adjust the time base slightly, there we go. That is very much like that. There's a little bit of ringing there. It's probably just my cable, but it does what it says it does. It just does a pulse, or whatever you want to do. It's got infinite cycles or single cycles, or I don't know how to use this properly, but gated stuff, positive negative polarity, internal again. So I mean, there's all these different options you can do in here. Number of cycles or gated, so it just keeps doing it on pulses. So if you've got an external trigger source, you can use that. And yeah, it's a lot to it, but I haven't really played around with this part of it myself either yet. But it shows, obviously. And if I just go back to normal parameters here, turn the burst mode back off. Normal parameters. So this is generating 9 MHz frequency right now with 1 volt peak to peak. And because the frequency is slightly out, as I was saying before, it's it's 10 MHz. Let's actually just put 10 MHz in, shall we? Right. I want to go up to frequency 10 MHz. So I'm putting 10 MHz output now. Going to the scope. It's reading exactly 10 MHz here. Okay, sorry about that. Just my wife sent me a text. So we've got the, where am I now? I've lost myself. Back to waveforms. So you can choose different ones. So square, ramp, pulse, right, and you can set the pulses fairly quickly. Let's do 1 MHz instead, shall we? And adjust my time base on my scope a little bit, and there you go. This pulses. Okay. Rise times on this, I'm not sure. I don't have those set up. Let's do we'll measure. Where are we? Rise time 16.6 nanoseconds. Full time 16.8 nanoseconds. Alright, or 16 point. Yeah, it's fluctuating slightly. Alright, but I know. So that said 16.8 rise time, right? Rise time 16.8. That's exactly right. So let's look at rise time, and it's see how low I can go. 1 nanosecond. Limited 16.8. Okay. So maybe frequency. It may change with frequency. So it may well be that a lower frequency you can get different rise time. So let's just change that and see if that allows us to get a different rise time. Let's do 10 kilohertz and try again. Still 16.8. Okay, so that might be the fastest it can do it. There's also full time as well, which is also the same. Let's see if I can do the same as well. 16.8 as well. So 16.8 does seem to be the fastest edge you can do. Let's have a look at higher frequency. Let's go maximum frequency, 30 megahertz. It's doing 12.5 megahertz on this waveform. So on this pulse, 12.5 megahertz is the fastest it can do. I go to a sine wave, 30 megahertz. Okay, so 30 megahertz sine wave is fine, but you can also do a 30 megahertz square wave. Now the problem is, because of my cabling and stuff like that, it's probably not looking great, but that's what's coming out. I may need to actually do 50 ohms. Ah, that's right. Now this has just caught me out. This scope, the 50 ohm here, is an indicator, like it is on the signal generator, on the arbitrary waveform generator. They're both indicators only. Alright, this doesn't load 50 ohms. It's just an indicator to show what it is, and also affects the calculations, I believe. Oh no, it's just an indicator. That's right. So this is going to catch a lot of people out. I wanted to do that, and I knew that this was only an indicator, and I still wanted to do it. This needs an external 50 ohm load in order to probably clean this waveform up a bit. Yeah, so watch out for that. Anyway, so but it does generate a 30 megahertz square wave, and most units don't actually do that. So ramp as well. Now ramping is limited in frequency to 500 kilohertz. So let's look at the scope. There we go. Nice triangle wave and 500 kilohertz. Okay. You know, it's doing what it's supposed to do anyway. That's what else we got here? Pulse, which we've already done, which is limited as well, which was, what was that limit to? 12.5 megahertz again. That's right. So that's what the pulse speed is maximum. Noise. So yeah, it generates literally noise, and you can generate. No, you can adjust how much noise it's generating and what it looks like. So let's go there. Turn it off. So there we go. That's the noise. Yeah, it's noise. So you can adjust those settings, but I'm not going to play with that. Next page. You also do DC. So if you want to try and generate a DC level, I'm going to a scope, so that's safe to do. If I was going to a Siglent generator, I really wouldn't do this because, Siglent generator, my spectrum analyzer, because it cannot accept any DC input. So if you're careful if you're playing with this, if you're on a spectrum analyzer, if you're connecting directly, it may not like it. It might blow up your front end. So be careful with this. Any DC offsets, if you're going straight into a spectrum analyzer, be careful. Let's do 1 volt and adjust the levels. So there we go. That is now generating 1 volt. Okay. So you know, it's fine. If you need like a reference voltage, I don't know how accurately this can be done. So it's 111 millivolts I've got right now. And RMS 111 millivolts. So that looks pretty damn accurate. Oh, my hands in the way. There you go. Okay, 10 millivolts. And it's starting to get a little bit of noise in there, but there we go, 9.4. So it's not bad. 1 millivolt. And this is getting right down the scope. It's 500 microvolt per division. That's really noisy. Let me just see if I can clean this up a little bit. Limit bandwidth. Yeah, that's alright. Just turned it off. And that's not going to be helpful, is it? Require menu. Memory depth maximum. Some averaging. Here we go. Alright, that looks a lot better, doesn't it? Let's get rid of that. And that is saying 300 odd microvolts. I mean, there's going to be a little bit of loss through this cable and stuff like that. It's not going to be perfect, but well, that's 1 millivolt output. Can I do less than that? 0.1 millivolt. Yes, I can. Right. So that is now trying to output 0.1 millivolts. So I actually think that is lower than what I could measure on the scope. I went 500 microvolt level here. It's not centered, is it? Yeah, it's just, that's right in the noise floor of the scope. Trying to measure that low. But, you know, I'm sure it's doing it. I just can't measure it. Yeah, so there may be a better way of trying to capture that, but no, I mean that's 500 microvolts, and yeah, that's right down there. So there's not much more I can do about that. Yeah, that's it. So there we go. So it can do these really small DC levels as well. Well, it appears to. Yeah. So it goes to 0.1 millivolts is basically the lowest it will go to. Its highest is 20 volts. DC offset is 10 volts. So it's 20 volts peak to peak. Sorry. All right. So that's what it does on the waveform. So. Yeah, there we go. So, yep, sure enough, we're getting 10 volts on the scope. So, 10 volts. 10.2 it says, but yeah. Okay. Right, so what else can I look at here? So that's the waveforms. Let's go back down to 1 volt here before I forget and leave it up there. Actually, no, I better set it to 0. Just in case. Arbitrary waveforms. Now, it's got a whole bunch of built-in ones, obviously. And you can obviously set frequencies, but the arbitrary waveforms are limited to 6 megahertz. We can't increase the frequency above that. We've got the various built-in types which are in here. They've added on to this significantly from earlier versions of this unit. So the early 1000 series, they had less built-in waveforms. They've added quite a few in now, so it's been expanded. They've obviously left more for more space for others that are still in there. I am coming out too far. You can also do the stored waveforms, which I actually showed a little bit on. It saved them by the looks of it. Really? Let's have a look. Nah, okay. Alright, there we go. It does work. So when you've imported it once, it stores it internally as well by the looks of it. So these are waveforms which I created using the coupled signal one here. So if I go back to here again, that one. There we go. So this is the waveform I created here. Look at the state of that. Right. I combined a triangle wave or sawtooth wave with some other waveform using that combined output thing. And I fed those back to the scope over here. Displayed that, it's basically that waveform on the scope. And then I saved the waveform into a CSV onto the flash drive. I plugged the flash drive back in here and fed that back in as a waveform. So you can actually create a waveform on here and then output it to another Siglent scope and put it back in, and then you've got a waveform, and it's actually remembered it. So as you can see, the USB is not currently plugged in. So the ones which it's remembered the ones that have been used recently. So it actually stores them internally, which is, I think that's a nice feature. I like that. That's really convenient. So once you've loaded it off the USB, you can take the USB out and you can still access it. What's this first one here? Oh, it's my first attempt. So I did a couple of attempts and playing around with different things, so it's the same thing again. So that's a really nice. I do like that aspect there. That's good. You know, if they actually have that, so it stores it locally. That's nice. What else can I show you? That's covered the. I think it's covered the arbitrary waveform stuff, isn't it? You also got the same settings you can use normally. let's just do, yeah, let's just select that one. So yes, it's a stir up. So yeah, it's all pretty simple, isn't it? This is all works the same way as the other like sine wave and stuff. It's all the same. Okay, I think I've covered a lot of it. Now, obviously, to switch between channels here, you've actually got a button here, which is channel 1, channel 2. Right, so you can have, I've currently got both set in the same waveform, actually makes it hard to see. So let's stick channel 2 on the square wave, there we go. Alright, so there you go, so you switch between those, and this is where you can combine them. So if I have it's 1 volt peak to peak on that one, 1 volt peak to peak on that one, it's a 6 MHz, 10 MHz signal. Come over to the scope, bring this up a bit so you can see it. Okay, so this is channel 1 right now. Okay, now if I go in to here, where was it again? Utility, output setup, wave combine, channel 1 and channel 2. Oh, that's right, square wave. Here we go. Square wave cannot be combined. Right? See, combining a square waveform is not possible. I don't know what the technical reason is for that. There probably is some reason. Maybe it's because they've got that whole high frequency square wave option in there. So square wave cannot be combined. Okay, so you have to watch out for that if you expect to be able to do that. So let's do a ramp instead. Okay, back to utility, output setup, wave combine, channel 1, channel 2 together, and there we go. A sine wave and a triangle wave stuck together. It's a bit messy, but it's doing it. Okay. If I go to channel 2 and change that waveform type again to pulse, there you go. There's a pulse with a sine wave joined together. So you can create some really interesting effects and kinds of waveforms just by doing that combination. If I stick noise on there, you know, that literally is noisy. I can put two sine waves together, you know, it comes up with this weird kind of, you know, waveform on top of a waveform. Triggering is not perfect right now, but no. So it's if I go into the arbitrary values and pick a, if I pick one of my stored waveforms, okay, so it is now combining my stored waveform with the output from channel 1. So go back in and I'll turn it to combining back off again. So yeah. Right, so that's back off. Yeah, it's very versatile in what you can do, and for the money, really, it's incredible. You know, the actual features on this are really good. Now, I've never actually had a proper AWG or waveform generator unit, even myself. Right, this is on loan. This is, as I said before, something that's been linked to me by Rob to play around with and review a little bit. So this is what I'm, you know, trying to figure out. So because it's new to me, I've had a bit of a learning curve on it, but it does what you expect it to do. Get a sine wave on there, so I'll turn the outputs back off again. All right, it all works absolutely fine. Waveform, sine wave. I mean, it's really easy to use once you get used to the interface. Things are fairly easy to find. I mean, stuff in the utility is a little bit trickier, but it's not that bad. It's just once you get used to using it, I think it's absolutely fine. But yeah, I do like these units actually. It threw me a little bit when I first started trying to work it out and use it, but I found a few little things which I think could be done better. Like I said, that counter option and the internal reference. You know, being able to set a calibration point for that internal reference, that'd be really good. Then you know for sure that your internal frequency count on this is bang on and that sort of thing. So you know, it's got some possibilities there for improvement, and because I fed that back to Siglent, that may happen. It may not. You know, it might be that there's too much development time involved and there's cost too much and there's not enough demand for that particular feature. Just because I suggest it doesn't mean it's going to happen. You know, so I think I've covered this in itself as much as I can. Now there's a possibility I'm going to be doing a side-by-side comparison of this unit with a SDG1032X, I believe it was. Rob was saying he's got one there, and he's considering that doing maybe a side-by-side comparison of the two would be good. The one thing I should mention is the purity of the sine waves and stuff on these. Actually, let's plug the scope back in again, see if I can see it. May or may not be able to see it. If I do a lower frequency, let's do 1 kilohertz, and try and get this to trigger and stuff. What am I doing? What have I got wrong here? I've got something wrong. I'm not seeing it on the scope. No, let's go higher frequency then. Oh, I did 1 hertz, that's why. Okay. So let's just see if I can see the... Yeah, okay. Maybe. Now, there are kind of steps in here. I don't know how well you can see that. The camera's not quite mounted right for this angle, but let's just try and get it right. Moving the camera closer to try and get a better shot. Hopefully that's falling off the mount. There we go. So you can, this has got a 14-bit resolution apparently, which in itself is not bad. I've seen a lot worse. I've seen like 10-bit and 12-bit versions of generators. Not Siglent, but some other brands. I think some Chinese stuff I was looking at before, and I never bothered with it because I thought, well, that's not really good. But you can just kind of see steps in there. If I just increase this amplitude a bit more, maybe it'll show up more. But it might just be screen resolution I'm seeing there. Maybe I'm getting some aliasing going on now because of the setup I'm using. Messing up triggering, but it might just be the screen resolution here. But you can kind of see steps in there. It looks very slightly jagged, you know. Very slightly. It's really hard to actually see anything. It might just be a bit of noise stuff. That's you know, 20 millivolts of division. That setting is right there. Can I page narrow the bandwidth down? That's not too much. Let's do too far. Indicator, call me out again. Right, so I'm just trying to see if I can, and it does look kind of like steps in it. I mean, it is built from steps, but I mean, the resolution's getting down there. So, I don't know. If I reduce the voltage levels, let's try that, shall we? Amplitude, let's do 10 millivolts, shall we? That should be trying to make this triggering a bit better if I can. Quite short trigger mode I'm using here. Here we go. See if I can get this a little bit better. Yeah, it's you can't really see it there. That's in the noise actually. So it may be with a high voltage output. Actually, it might show up more. Let's just try that. Let's go 10 volts. Bring us down some more. A lot more. I mean, you can see there's steps in that one. Oh. Yeah, I mean, you can see steps in there. So it looks like with the higher voltage, that's what makes the steps show up. Possibly, it might just be the way the scope is displaying it. It seems to be a bit variable, but yeah, you can kind of see steps in there, but it might just be the sampling of the scope. That's entirely possible. require more, give it more memory depth. I'm at 14, too far again. That may help it. I mean, it does look like steps in there, and that's what I was expecting to see as steps. Yeah, so I still see it there. That's in the noise there. So not easy to capture, but there are. I mean, you can see steps there. So I think that probably is what's really trying to be covered. Right, so 14 bits. And the 2032X is supposed to be 16-bit resolution. So even on that, you know, as I was just shown, you can't really see it. You know, there's just a little bit there. You know, so how much that really matters, I don't know. You know, if it's less than 12-bit, then yeah, it's going to be quite bad. 14-bit seems to be okay. I think that's an acceptable level based on what I can see on the scope there. You know, you can see little bits of steps there, but it's really small and it's really hard to even see it. What's the other things I can cover on that? Yeah, I mean the specs are there. You know, download them, have a look on the Siglent website, or you know, all the data's there on these things. So I'm not going to go too much into that, mainly because I don't have it in front of me. So I think that'll do for now. So yeah, let me know what you think, and I will likely add on to the end of this video with, or maybe do a second video. Actually, this is getting quite long, so probably a second video with the side-by-side comparison with the 2032X. That's likely to happen, so we'll go from there. But that'd be good to just do some feature comparisons. If there's any real difference in settings, I think they're pretty much the same firmware. It's very similar, I believe. There's not that much difference in them. They even look very similar, the actual units. So I don't think that's really much of an issue. So let's just get a better camera shot. Here we go. Alright, so catch you later. Have a good one. Let me know what you think. I'll stick it on there. Don't forget to subscribe, which is like there. And I've probably got some other cool videos up here and stuff. Catch you later.